So let's start now. Yeah, it's the same thing. Do you have it? So this is just a summary that I made from chapter 1 to 6. It's just some basic concepts and equation there. So if you have no time to go through that, you can go through here and start to do the question. So today we will focus more on the question that you posted on the website. So it's here. Yeah. You get this? No. Is there an extra? Oh, okay. Okay, that's the last one? Right, 2. Okay, just leave it there. Yeah, just leave it there. Okay. So there is 2 samples for the exam 1, sample 1 and sample 2, and I think we'll just go through for sample 2 first. You're gonna what do you think, like that's the sample 2 or sample 1? They're sort of different. Yeah, it's not going to be this is past your question, so like same difficulty, but you won't give up the same question. I mean, not the same question, but like, those were the yeah, maybe the sample 2. Yeah. But it changed the sample 2 now. Oh, we just didn't change it. Yeah, it changed to. Do you have the old one? No, I got the old one. This is the one I took it last fall. This is like the. Yeah. So we do this. Everyone haven't done this, right? So we go through this. No, there's 3, but for question 2, I guess this is for chapter 7. Is it? This is for chapter 7. It's not going to be like that. So we just go through question 1 and 3. Then we'll go to sample 1. Yeah. Okay. Yeah. So we'll spend 10 minutes on this and we just go through the question and try to solve it by our own, and we discuss it after 10 minutes. So there is 2 bar and the information is given here. Yeah. Is it better? Okay. So this is 2.4 inch square. So, how is it? I couldn't see a number up here, but it's fine. Just go through this. And he say after the temperature change, there is a strength in the bar which is equal to negative 11 psi. And he's asking you for the temperature change. So you have to look for the delta T, and he's asking you for the length of gravity. Just raise your hand if you know anything about the gravity. So we'll spend like 10 minutes for this question and try to do it by your own, and we'll discuss it later. Yeah, the breath is like you're looking for the time that.
Wait, no. Is that alpha and the minus?
Oh, sorry, this degree Celsius should be Fahrenheit. Okay, so let's go through the question now. Anyone know how to solve this kind of question? The answer is here. It's like 200. No, I'm not sure because I don't know about this one. But let's go through the steps. So if you got the steps right, then it should be fine. Just like calculation error. Okay. So there's And so for this kind of question, and usually you will have to look for, you have to use this equation, which is rate total plus rate is equal to, because there is a gap here, so they can, it means they can default for this gap. And if there is a, okay, let's say this way. If there is a temperature change here, and this thing elongate, and you reach this point without touching the wall, will there be stress in the bar? No, right? So in this case, this thing is deformed all the way down here, and it's pushed back by the wall. So there is a negative force that push back the part. So that's how we get. So this the thermal strain, which is all the way down here, and this is the force by the wall, which is this part, and it's equal to the gap. Anyone got this one?
It's the deformation of the wall.
Yeah.
The which length do you use? The length of the or
I made a mistake last time that I talked about. I say it's the total length, but in truth it's the length of the original length. Yeah, it's the original length. Okay, so with this, we should be able to solve it because we can change this into delta T times the length. Everyone know this equation, the thermal strain is equal to alpha delta T times the length. In this case, they got the same alpha, so we can add the whole length here. Everyone got here? Okay. And so the thing is here. So here, for this part, let's say this is bar 1 and this is bar 2. So for bar 1, under the force is going to be equal by F1 L1 over E1 A1. And for bar 2, it's the same, it's F2 L2 E2 A2. So let's put this in. So F1 L1 E1 A1 plus F2 L2 A2 E2 is equal to the gap, which is 2.5. 0.02. What inches? Okay. So you'll be able to solve this because you are given this and you are looking for the delta T here. So the delta T here is unknown. Okay, so we keep it as delta T. And the length will be the total length. Everyone know why is the total length here? Yeah, because both things they have the same alpha and they are expanding together. The alpha is different or two? Oh, okay, okay. Sorry. I need to go through a question with you. So I have to write it to alpha 1, delta T, alpha 2, delta T. Okay. So, sorry, I made a mistake here. So they got a different alpha, so I have to separate it into two parts. So the alpha 1 is given, delta T, you are looking for delta T. And L1 is given. And the same. It says the delta T is going to be the same. And alpha 2 is given, we keep the delta T here, and L2 is given too. So, okay, let's go to the next part. What? Yeah, F2 is not given, but we're going to solve it later. Okay, so let me see the question. So at here, he say the aluminum bar. Let's say he say the stress in here is equal to negative, right? So we'll be able to solve for this, which is for this one, F1 over A1 will be able to solve, which is equal to negative 11. Because 1 is aluminum. So stress equal to F over A. And stress 1 is equal to F1 over A1, which is for aluminum. So we just put the negative 11 into this part, which is F1 over A1. Everyone got here? Okay, so and the L1 is given again. So we can plug in the L1 and E1 is given. So the next thing is about F2. So the stress is going to be the same for the whole bar, no matter it's bar 1 or bar 2. But here you have to look for F2. Oh, I'm sorry. The F is going to be the same, not the stress. The F is going to be the same. So for there, F1 over A1. So you got the stress 1, you got the A1. You can solve for F1. Yeah? Everyone got here?
Which area would be A1 as the aluminum?
Yeah, because we said that's F1. So we'll go to stress 2 is equal to F2 over A2. And the stress, let's say, the bar looks like this. If there is a force here, it's a force, if we cut it, you will see the force at these two parts is going to be the same. Okay. Do you guys want me to prove this? Or you guys are okay? There is a force here, the force in here and the force in here is going to be the same force. Okay, so we can say F1 is equal to F2. So since we calculated F1 through here, we can plug it into F2. And we got the A2, so we can solve everything here. F2 is, we got F2, A2, L2, and E2.
So F1 is the F2, just...
Let me, okay, I'm going to show you that. Let's stay here. Okay, so this is bar 1, this is bar 2, and this is F. So if we cut here, we can see that let's say this is F1. Is F1 equal to F? This is the direction is different, right? F1 is equal to F. Okay, let's cut here. So if we cut here, it's going to be there is only one force here. So let's say this is F2. Is F2 equal to F? Right? Okay. Solve your question?
Yeah.
Okay. Yeah.
You said that normal structure over here, right?
Yeah.
And the area is different from 1 and 2.
Yeah.
But the stress is big.
No, the stress is not there.
Is that the level?
You just use that in the area to find F1
The force is the same, but the stress is not as huge.
Oh, yeah.
Don't get confused there. So F1 is equal to F2 here, and we can plug in F2, L2, and A2. You can calculate it. E2. So everything you got just, and there is only one unknown, which is delta T. So the value for F2 is the same value. You mean for F2 and F1? Yeah, it's the same. Just we show you just now. So you got this one. So that's why F1 is equal to F2. Because there is no force in here. If the question is there is a force in here, the force in bar 2 is not equal to bar 1. You have to count it and see. Because in this case, there is only one force at here. So the force in the bar 2 is equal to the force in the bar 1. Everyone got here? So we can calculate the delta t. And that's what the question was for the first part, delta t. Okay. Anyone got a question here? So for the problem exact length. So okay. So the question B is asking you for the exact length for the aluminum bar. Anyone know how to solve part B? He's asking you for, because this thing is going to expand. Maybe this bar is going to expand like this bar. He is asking you for the aluminum bar, how much it expands. So just how you calculate it for bar 1, the total is going to be the thermal plus the force. So this is equal to alpha delta t times the length. So everything here you got, right? Alpha you have, delta t you calculated, you get it from problem A, right? And L is 18 inch. So, and this part is equal to FL over 2A. And F is equal to, F over A is equal to negative 11 KSI. Everyone know why F over A is equal to negative 11 KSI? Yeah? Okay. So, and L is 18 inch and E is even. So you can calculate the total deformation here. And this is going to be negative here, and this is going to be positive. Because at here the force is equal, is a negative force is compressing the bar. Okay, so depends which one is easier here, but at here this one is negative and this one is positive. Yeah. If you guys got this, there is a few questions that is exactly the same, and we will go through. Simple one. Okay. Okay. Yes. Okay. So do you guys understand? This is basically the same idea, but this one is a little bit harder because there is a force here. You have to consider a force. So try to think about how you would do this one by the knowledge from the previous question. This one. Yeah, this is from step 1. Let's try it. Yeah. Just try to think how you would do it. You don't need to calculate the answers. Just try to write out what's that. If anyone has a question on the previous question, you can raise your hand and I'll put you for the previous question. try to think this as 2 bars, like having here. Because the parse in 2 parts is not going to be the same. So we'll go through this one now. Anyone can solve this one or have any idea on solving? I think we got it. Okay, so these are all the information given in the question. And they say that the temperature change is 100 degrees Celsius because at first it's 20 degrees and the ending temperature is 100 Celsius. So the delta T is 100 degrees Celsius. Okay, So basically we'll do the same thing again. But now, although the bar is like the same here, we're going to separate this into two parts. Let's say this is part 1 and part 2. Okay, so as usual, right, delta 1 plus delta 2 is equal to get. So for delta 1, there is delta turbo plus delta S plus delta turbo 2 plus delta F2 is equal to get. Everyone got this one? Right? Okay, because at both parts there is going to be a turbo deformation and force deformation. Okay, so for this, the delta T1, okay, the delta T1 is going to be alpha delta T times the length, which alpha is here, and delta T is 100 degrees Celsius, and length is 200 millimeters. So we got all this here. Okay, let's go to the next one. The next one is for this part. For this part, it's asking you for the force, for the deformation by force, which is FL over EA. Okay, I'll write everything down first now. L2 plus F2 L2. Okay, everyone got here? If this turbo is going to be alpha delta T times the length, it is going to be done by a force, it's FL over EA. But in here, we're going to separate in two parts because the F1 and F2 is not going to be the same. Okay, and the L1 is equal to, I'll do the F1 and F2 later. Let's look for the unknown. So we don't know about F1, but we know about L1, which is 200 millimeters, right? The E1 is even, E is the same for E1 and E2, even there, because it's the same as 0. And A1 is given as well. A1 is given in the original question. Yeah, but I didn't write it here. Millimeter squared. Okay. So, where is it? This picture. Oh yeah. Yeah, here's a picture. So the A1 is given 120 millimeters squared. So I'll go back to okay, so L1, E1, and A1 is given. L1 is 200 millimeters, E1, A1 is given. And alpha is given, because in this case alpha is the same. They're the same material. Alpha is given there, delta T is given, and L2 is given again, which is also equal to 200 millimeters. And now we don't know about F2, we know about L2, E2, and A2 here. Everyone,
E2 is the same, right?
yeah, A1, we are the same size bar. Yeah, everything is the same. Okay, so now we'll solve for F1 and F2. I'll wrap this up. Okay. So now let's see. If this bar is going to expand to look like this all the way down, let's say if the wall is going to, if there is no wall, the bar is going to expand all the way. So there is a wall here which pulls the bar back. So there is a wall here. Because the wall is going to push the bar back, there is actually a reaction force done by the wall here. So there's the FR here, and there's still a 10 kN here. So for this, the first part, we have to cut this because we don't know about the inner core, the tissue part. Okay, let's cut it up here. At this part, there is FR. And let's say this is F2. So you can see F2 and FR are equal, but there is a negative sign here. Everyone got here? So when we cut here, which is, let's say this is F1. There is the FR here. There is a FR at the end, and there is a 10 kN here. So 10 kN minus F1 minus FR is equal to 0. So F1 is equal to 10 kN minus FR. So we arrange this and we can see that F1 is equal to 10 kN minus FR. Everyone see this? So now we got F1, so now we write everything in FR form. In F2 is equal to FR and F1 is equal to 10 kN minus FR. So we can plug in the original equation, which there's F1 and F2, but now we only got one unknown, which is FR. So we can solve for FR now. That's how you do this kind of question.
I'm sorry.
Which part is complete?
Just like the solving.
Oh, yeah, how you raise everything.
No. For like X1. What you just said.
Okay. So I put this. I will put F1 is equal to F1 is equal to negative FR here.
F1 is equal to FR.
Negative FR.
Negative FR.
And F2 is equal to sorry, F2 is equal to F2. F1 is equal to F2.
Okay.
So you can plug it into all the pressure, which is F1 and F2.
Okay. So then you have F1 equals to,
So you can plug
like, same thing as plus F2.
your mind like
Yeah.
So there is a few questions that look like this.
Do you know what stuff like 20 will be on there? Like what? You don't pass a question at 20.
20? I don't think so. Yeah. This study guide one is for a whole semester. Yeah. So you just need to go through. I think it's question 16 or
Yeah, like question 15.
15. Yeah. So you just need to go through till 15. Go through till question 15 and you're done. I think just but for no, this is sample 1. There is no sample 3 here. There is only sample 1 and 2. So I would like to go through. So after you go back, try to do this question 4 and question 5 because it's the same thing. You just make sure at least you have to know this type of question. I don't know if you come up with this type of question, but yeah, just kind of go through this. Okay, and I want to go through. Okay. So I would like to go through one thing about cards because I guess some people are not so familiar with the card. So let's say there is 2 bars here, and there is a force here. And so this is bar 1 and bar 2. So in this case, if you want to cut this right here, let's say I cut it here and here. The first cut will look like this. This is F. And always draw in the outward direction, no matter which way are you cutting. So if this is F and let's say this is F2, alright, negative F2 plus F is equal to 0. So F2 is equal to F. Okay, let's cut this off. So this is F, and let's say this is F1. You see, I always draw in outward direction, which if the face is here, I'll draw it this way. So negative F1 plus F is equal to 0. And F1 is equal to F. In this case, you won't get any confusion. If you have to look at this way, it's the same thing. The cut this is very important because you will need this for almost all the questions. If you have to look at it this way, like the first cut is going to be here, which is this part. I will draw in this direction. Notice the difference is when you are always draw to the outward force, so this is F1. And let's say, if you are looking at this way, this is F. The outward is F1. You can see these are different because I'm looking at different ways. Always draw to the outward direction and you'll get a constant answer or you'll get confused. So if you are looking at this way, you have to find this first, which is FR. FR at here is equal to negative F. Everyone see here again, if there is a FR here, FR plus F is equal to 0. So F is equal to negative FR. There is no FR in the original question, but if you want to look at it this way, you have to add in the FR. Because there is a wall here which provides the reaction force to the bar. So let's say F, so we can solve here. FR plus F1 is equal to 0. So F1 is equal to negative FR. But we got here FR is equal to negative F. So at here F1 is going to be positive F, which will get the same answer here. Let's say negative F1 plus F is equal to 0. And we'll get F1 is equal to F. So if you always draw in the outward direction, you'll get the same sign as the correct answer. Do this to the torsion as well because there is direction in torsion. Okay. Yeah. Do you guys have any questions for me? Is it? So if I prepare the exam in this way, I go through all the questions that you gave on the website and I'll go through the homework and do like maybe 1 or 2 questions. I mean, at least 5 questions for each chapter if you want to like score a really good grade. You have to go through all the question types so that you won't get anxious when you receive the test paper. You have to know, oh, this kind of question, you have to do it in this way. Okay. Try to do it between today and tomorrow because there is one more review session tomorrow. If you got any questions, just bring it to the review session. And we will go through the other sample questions about hope, which is chapter 6 tomorrow. Yeah. Can you guys write your name down and student ID before leaving? Thank you. What is the first one? It's the one that we did right before this one. Is it the original from the sample too? Is it this one? Yes. Okay, yeah. There was people interview about this temperature and pushback label. How much is the plan and pushback? We really have to solve that. Say we're giving this information, we're also giving information here and here. That's so all of it. Usually, just even if you have like to us to define course or to define the most basic efficient of the work. So, yeah, there is only one above there. This is very good. We use situation with our to get and we have to look for one more. So in the second where you said this is equal to delta, you just said that delta actually is changed. Basically it's the same idea. Here about that, how about here we just made this down. Okay, because you were using delta like for stress and for confusion. So that's what's yes, that's the one that you read also when you're I just actually has to be a a gente encaixa a temperatura de esses travelers e vai ser uma conversa só com a parte de normal. Essas são bastante so you're going to forward again. I will support that. So you can get a so then like here it has delta 1 and you set delta 1 for
Realmente, quando eu sabia, eu já vou lá.
So you
Se você só chega na hora, você vai tomar com a gente, ele vai dar férias. Aí eu tenho que dar isso, aí eu tenho que deixar em função das coisas, sabe? Aí eu só já é.
Because the first part of my the whole bar, it's by a whole bar. But the second part is and I would only on because you got temperature. Yeah, so you got everything.
Eu fiz sucesso, lá.
You have
Aí eu tinha que fazer mais esse aí a chave então logo lá, para mediar. A gente fazia o mesmo que já era.
Now you just consider the aluminum and don't care about the for us and because when I was originally looking at it, you have to also use the because you got a fourth and a fourth is the fourth that you bring and the temperature is yeah, then you're
All these questions from the yeah, and all of them I can find on this website. But can you enter the first page of the website for me to?
So this is a website that you know this website. So you look for the homework. So you just need to go through sample 1 and sample 2 here for exam 1. The sample 3 is the same thing as sample 2. Yeah. Yeah, so we just go through problem 1 and 3 and I'll go through problem 3.
So it's good for me to redo all the going one page.
Yeah.
So it's good to me to do just sample 1 and so what about sample 2 and sample 3?
Sample 2 and sample 3 are the same, so you just need to go through
sample 1 and sample 3.
Yeah, okay. Go through this and go through the homework.
And this is about the next.
Yeah, the next.
Okay. Yeah. Do you know who is the person that corrects the homework? Is it you?
No, it's not me. It's a TA, but I don't know who is it.
You are not the TA?
Yeah, I'm not a TA. I'm just like doing review session every week.
Okay.
Yeah.
But you have already done this subject.
Yeah, I done this last fall, so that's my exam last year.
Okay.
Thank you. No problem.
Which was your grade for that subject?
I got an A for this one. Yeah. Just basically, I got like 24 to 25 out of 30 for those exams, and I get an A. And the homework is fine because I think he gave full marks for the homework. I'm pretty sure.
But I don't know what happened to my lesson. He gave me 0, but I did it but the same way that I did all the others.
I think you should go to a TA and I think
I will go because I gave it late to the professor, but I explained it, but it was like the class ended and I went some few minutes later to his office and gave it in person.
I think it should be fine. It's just like the TA forgot to get it from professor. Yeah, you won't get a 0 for it. Yeah.
Thank you.
No problem.
See you.
Okay.
Tomorrow we are going to do the review of chapter 6.
Yeah, chapter 6.
Just chapter 6.
Depends on what you guys think, but I'll go through the question 3 and go through chapter 6.
Okay. Yeah, and if you have any doubts about this stuff.
Yeah. Okay. See you. Okay, see you.